This is the point where we're going to start to try to memorize how to do these FRQs. And so I'm going to do one of the one sample, and then you guys are going to do one of the one sample, and then we'll do two sample, and then you guys are going to do two sample, except for it's not going to be in that order because I'm going to do one, and then I'm going to do one, and then you're going to do one, and you're going to, anyway. Okay. I'm really special today. It's Tuesday. It's awesome. Okay. M&Ms claim that 15% of all M&Ms are brown. Suppose you got a bag of 78 M&Ms, 18 of which are brown. Is there evidence that their claim is underestimated? Okay, evidence means that they're looking for a yes or no answer. So I want to do a hypothesis test. I know it says it right here, but I'm just trying to help you for the AP test. And in a hypothesis test, you start with the state. And in the state, you want to do three things. You want to state the hypotheses, define the parameter, and state the alpha level. Okay, so is this problem working with proportions or means? Proportions. And is it working with one proportion or two proportions? One. Okay, so the null hypothesis, the HO, as we like to call it, is P equals 0.15. It should always be an equals. It should always be a plain letter, no hat, because it's what you're estimating. And it should always be what you assume if there's nothing interesting going on. Okay, now the alternative hypothesis is that their claim, this claim here, is underestimated, which means we suspect that P is greater than 0.15. Okay, and P equals the true proportion of all brown M&Ms. And when they don't give you an alpha level, what do you use? Yep, 0.05 is a nice happy medium. Now for me, if I was doing this problem, the hardest part for me would be to take that word underestimated and have the thought process that that was going to be greater than or equal to. And I will give you a way to check that in a minute. So let's just say you said underestimated. You're like, under, that's less than. Okay, I'm going to give you a way to check that in a second. Do you have any feeling like you might say less than if you saw under in there? No? Yeah, it's possible. Okay. All right. So then we have the plan. One sample Z test for P. Random. Okay, so the problem doesn't say anything about random, but I'm telling you we have an FRQ, so we have to keep going. So what do? Assume. Oh, this is just going to make me hungry. Check. 10%. N equals 70. This is why we use erasable pen. 78 is less than 10% of all M&Ms. I think that's probably safe. Probably more than 780 M&Ms out there in the world. Okay, 18 is greater than or equal to 10. And 78 minus 18 greater than or equal to 10. No, I can't do that. That's lazy. 78 times 0.15 greater than or equal to 10. 78 times 1 minus 0.15 greater than or equal to 10. Seven. I'm probably really close with my 18, but not good enough. That one was pretty close there with the 11.7. Woo! Just barely over 10. Am I having just too much fun over here? Yes, yes, I am. Okay, now let's pause here. Any questions about the state or plan? Okay, do. Okay, so standardized test statistic. I'm on my formula sheet now. Standardized test statistic is Z. So we're going to go Z equals statistic minus parameter over standard error of the statistic. Okay, so the statistic is P hat. I'm going to calculate P hat over here on the side, which is 18 out of 78. Everybody sees the word statistic. Hopefully they say statistic starts with S. That's sample. No? Statistic? Sample? Okay, so statistic minus parameter. Parameter is P, which you get from the null hypothesis. Okay, and then flip your formula sheet over. Which thing am I doing right now? Test, test, test. Not test, test. Sorry. Okay, so we want square root P times 1 minus P over N. Any questions about where those numbers came from? You guys know what the statistic is and the parameter. Statistic means sample. Parameter means population. Standard error formula is on the back. Okay, now calculator time. We're going to go with 1.98. What's wrong? Did I do something wrong? Okay. Now this is the moment where I said, if you weren't sure what way to make your arrow in your hypothesis test, this is where you can check. My answer, my z-score is positive, so that means that I should be going in the upper tail, which is greater than. So this is positive, so that should match that going toward the positive. So if you weren't sure about that, that's the moment you can check. Yes. Okay. Let's say you were doing this problem and you said underestimated and you put less than because you just weren't sure. And then you do this calculation and you get a positive z-score. That's when you realize, oh, positive z-score is going to be in the upper end of the curve up here. So I wanted to do the greater than, not the less than. If you got a negative 1.98, then this should be less than. Because we're working in the tails. It's just a way for you to check yourself if the wording's not clear, like underestimated. I feel like for me, if I was your age and I was taking a test, I'd be like, underestimated, that's down. And, I don't know. Just how I feel like it would happen. Anyway, p-value equals normal CDF. And I can look at my little picture. So low is 1.98, infinity 0, 1. 0.0239. Hence our p-value of 0.0239. Okay. Now you want to go back and compare it to alpha. Is it less than or less? That's good, right? We want it to be less. Okay, so since it's less than alpha, we reject the hope. That means we do have convincing evidence. And then I come back up into the problem that their claim is underestimated. So that no. Let's look at my little picture here. So 1.98 is on the positive side. So that would be here. And then infinity would be here. You see what I mean? So if it's negative, it would be negative something, negative infinity to negative that. Okay, flip the page over to the next one, whichever one's on the left side of the two sample. When you're ready. There's the whole thing there in case you want to see it. I know. Okay. A sleep foundation studied a random sample of baby sleep habits. The sample was stratified by region and gender, so an equal number of boys and girls were studied. Of the 999 sample, 37% of babies woke up to eat at least once a night. Split into two age categories, 39% of the 811 babies under 6-month-old woke up to eat at least once a night, compared with 26% of the 184 babies aged 6 months or older. Is the difference of 13% real or just natural fluctuations in the sample we've chosen? Okay, this is, I mean, you're going to crush the hopes of all moms everywhere if it's not real. So it better be real. But anyway, okay. So you see a problem like this, you say, all right, you got a difference. You can tell that there's age group gap, so that's where your two proportions comes in. The word difference really is the thing that's going to tell you. And it's asking you a yes or no question, so that means you're going to do a test. And I feel like we should go slower on this one because it's got some nuances. Okay, so let's go slow. We need to do 3 things in the state. The first is the hypotheses. As I said yesterday, every single one of these has the same null hypothesis. The null hypothesis is that there is no difference. So P1 minus P2 equals 0. Same null hypothesis every single time for a difference of 2 proportions. Every time. Every single time. All the times. All of them. Okay. Now, we need to decide if this particular problem is greater than, less than, or not equal to. How do you feel about the wording here? It says, is the difference real or just natural fluctuations in the sample we've chosen? Is it talking about it being more than or less than? No. Doesn't it sound more like not equal to? Yeah, okay. And this is good because we haven't really done a lot of these, so that's going to help us practice. Okay, now I have to label which one is which. I'm going to say that the 6 months, under 6 months is going to be group 1 because it was mentioned first. And then the 6 months and older will be group 2 because that was mentioned second. That's my scientific way of choosing. And I need to do one more thing in the state, and that's alpha level, and it doesn't say 1, so I go with my happy medium. Then 2 sample Z test for P1 minus P2. Random? Anything? Yeah, it's actually stratified random samples. Woo! Just happened. Will I get marked off in a test if I don't note that it's stratified? No. Okay, what is the sample one size? 811? Adorable babies? I think there's probably 8,110 babies under 6 months. 184. Why the difference? Okay, we have to pause here, especially if you're absent yesterday. I'm gonna seem like I'm talking a different language. So get your formula sheet. And we are going to use p-hat combined for our large counts proportions. So p-hat combined, to remind you, is success plus success over sample size plus sample size. We pool them into one big sample. So p-hat C is something. Okay, so it looks like it's 0.37. Oh, they gave it to us, didn't they? They cheated. Okay, you're never ever going to have that, no problem. So we're just going to go here. Okay, so let's see. 39% of the 880, 811, 0.39 times 811. So that's about 316 babies. Little babies woke up in the night, and then 26% of the 184 older babies. That's about 48 babies. And then there was 811 total babies and 184 total babies. Yeah, I feel stupid. Does anybody know why I feel stupid? Yeah, it gave us the thing and the problem. But you see, the problems aren't going to have that. You're actually going to have to do it. So, okay. So, sample one. N times p hat combined greater than or equal to 10. N times 1 minus p hat combined greater than or equal to 10. Second sample. N times p hat combined greater than or equal to 10. N times 1 minus p hat combined greater than or equal to 10. Do you guys trust my previous mathematics? So this one is 296.8. This one is 514.2. This one is 67.3. And this one is 116.7. And it is coming down. Okay, we're close, we're close. Okay, do. Same formula, standardized test statistic equals, so Z equals. And the statistic in this one is P hat 1 minus P hat 2, which is not the same thing as this up here. It's 3016 over 811 minus, actually, I'm so stupid. Didn't they just give me percentages up there? 39 minus 26. Okay, so that's the statistic, 0.13. The parameter is P1 minus P2, which is always 0, because that's what's in the null hypothesis. And then go to that crazy formula. What? What? Oh, yeah. Okay. P hat C, 1 minus P hat C, 1 over N1 plus 1 over N2. Ooh, that's a big Z-score, 3.30. Oh, excellent question. Um, I usually go with the sign that it is. So if it comes out positive, then I'll go that to positive infinity. It it doesn't matter because we're gonna multiply it by 2, if you remember. So when this is not equal to, this is kind of a plus or minus right here. Okay, so I have 0 point, actually we're gonna write this here. Let's write it in scientific notation. 4.83 times 10 to the negative 4. And then because it's not equal to, we're going to multiply that by 2 because it's got both tails. Don't get freaked out by scientific notation. This just means it's tiny. That's a good thing. You want it. If you get scientific notation, you should like do a little, one of those like jump up and click your heel things. Like a leprechaun. What? Heel click. I don't think I can do it. I'm too old. I'll break a hip or something. You know what I'm talking about? Who in here is dancingly inclined? Courtney is. Nami's dancingly inclined?
She is. Or Bruce. Brush my way. You should see Ryan.
Well, I definitely know that this is less than 0.05 because there's 3 zeros in front of this because of the -4 exponent. It's teeny tiny. If you're ever freaking out about that, you can go back to math 1 in your mind and go, what is this actually? 1, 2, 3, 4. That's definitely less than 0.05. Just in case you need that in your mind. Okay, anyway. Again, we had to prove that real because otherwise all mothers everywhere would be extremely upset. Everyone looks forward to that time when the little baby actually sleeps all the way through the night. It's an amazing thing that happens. So you wake up and you're like, oh no, is it okay? You run over there and it's totally fine. You're like, it slept through the night. It's amazing. And then you do that little heel clicking thing, just the same thing that you would do if, say, if you got the reject the null hypothesis. Except for that you've had 6 months of sleepless nights, so you can't really do it because you're exhausted. It's real. Anyway. Okay,